So our last page of our week 8 concept check is over calculating heat of reaction. So this was something that we went over in the first part of energy in reactions lecture. And this is what homework 6 will look like. Again, there's a practice homework 6 as well. But let's go ahead and go through this. Even though there's lots of examples on Canvas, I think doing another one is always worthwhile. This is something that hopefully everyone feels comfortable with the process here. And this is a problem that everyone will do well on the third exam. So the idea here is that we just add up the bond energies for the reactants and the products. And so this is energy in to break bonds. And then when we make bonds, we get energy out. And so you'll always be given a table of bond energies. And so the idea is you come in and you say, okay, what is this? This is a carbon-hydrogen single bond, which is 415. And so each one of these is 415. And so I come in and I like to kind of make sure that I label each bond so I don't miss any. So there's 4 bonds, 4 carbon-hydrogen single bonds at 415. And then here I have an oxygen-oxygen double bond, right? And so again, make sure the type of bond matters here. And so what I'm going to do is I'm going to come in and each one of those is 494. I've got 2 of those. And so when I add that all up, this is 1660 plus 988. That's a total of 2648 kilojoules per mole of energy in. I'm going to do the same thing on the other side. And so I come in and I say, okay, I've got a carbon-oxygen double bond. And that carbon-oxygen double bond is 805. And I've got 2 of those at 805. And then over here, I have an oxygen-hydrogen single bond. And so I can find that over here. And each one of those is 460. And I have a total of 4 of those. And so again, I can add this up. This is 1610 plus 1840 for a total of 3450. And so let's think about the delta H here. The delta H then is the difference between the bond energy in on the reactant side and the bond energy out on the product side. And so you want to subtract those. And so here, if I'm getting more energy out, I'm going to end up with a negative number, right? So again, I calculate this by taking 2648 minus 3450, which is going to give me negative 802. And so I have a negative delta H. That means I have an exothermic reaction. I've gotten more energy out than I put in, right? And this is burning combustion of methane. And so we burn methane because it gives off heat, right? If you had endothermic, you would have a positive delta H. The other thing I want you to be able to do is write an equation from what's given to you. It's already balanced, right? You just have to turn those Lewis structures back into formula. So just look at everything that's bonded together, right? And then count your letters. So inside that circle, I've got a carbon and 4 hydrogens. So that is a CH4 molecule. All right, but there's just one of those. So my coefficient is 1. And that's reacting with those 2 oxygens are bonded together. It doesn't matter if it's a double bond, right? That's not part of the formula. But I've got 2 of those, right? So my coefficient here is 2. And then that's reacting with this molecule that's got a C in the middle and 2 oxygens. There's only one of those. And then I have an oxygen bonded to 2 hydrogens. So sometimes you could write OH2 since oxygen's in the middle, but typically, right, this is water, and so we write water as H2O. And we've got 2 of those. And then what we want to do is we want to include energy. And so if you have an exothermic reaction where you're getting energy out, it's a product. And so you can add energy as a third product here, right? So if it's exothermic, energy is a product. if it's endothermic energy, would be a reactant. And again, there's an exercise that basically just gets you into thinking about how delta H, exothermic, endothermic, product, reactant for energy are all kind of related. I want you to get, very versed in talking about those things in several different ways. All right, so that's the end of our packet. You can now complete homework 6 and get that taken care of. As always, thank you for your time.